Hello everyone, my name is Adel Valle. So I will be discussing today about the topic apportionment by Hamilton Plan. So this apportionment with Hamilton Plan was first discovered by Alexander Hamilton. Its first proposal was approved by the U.S. government year 1790. So, what's the purpose of this Hamilton Plan? Based on my understanding, its purpose was to distribute fairly the population in each state. Like, let's say for example, if when we divide things, then we want to divide it fairly, we can use the process in order to calculate the apportionment by the Hamilton method. With the use of Hamilton method, we must follow the four basic steps. So, four steps. First, we must calculate the ST, or they call down standard device. Again, ST stands for standard device. So, what is this? How to calculate standard divisor? So, in order for us to get the standard divisor, we must know in the problem, or we must read the problem, or we must get the total number population over the total number of people to apportion. So, total number of population divided by the total number of people to apportion. With these two basic steps, we can now get next step, or the second step that we must apply in calculating the apportionment by the Hamilton Plan is we must get the quotient. We must get the quotient. So, how to get this? So, in order to get the quotient using the apportionment by the Hamilton Plan, you must get the total number of states over the calculated standard divisor that we calculate during the first step in Hamilton Plan over standard divisor. So, again, in order to get the quotient in our apportionment by the Hamilton Plan, we must get the total number of each state divided by the standard divisor. So, by following with this, we can now get the ratio or the quotient that we are aiming for. In order for us to proceed also to the third step. The third step that we must apply in using apportionment by the Hamilton Plan is what they call standard quota. In order to get the standard quota is we must round down the quotient that we have solved during the second step of our problem. So, round down into the whole number, or round down the quotient quotient to a whole number. So for us to understand more fully, so I have an example. So for example, the quotient that we get during the second step of our problem is 5.0001. So as we can see, there are 4 decimals here. So based on the steps, we can round down the quotient to a whole number. So round down the quotient. So we must cancel this decimal. So the quotient or the standard quota remains 5. So this is now our answer for the third step of the apportionment. Again, third step of the apportionment is the standard quota, which we must round down the quotient that we get during the second step of our apportionment in order to get the standard quota. Our last step, which is the fourth steps in calculating apportionment by the Hamilton plan. So our last steps indicates evaluate your answer. But take note that if the answer of the representative obtained does not sum up to what is desired or to what is expected, additional representative will be given to the largest decimal remainders during the quota calculation. So this happens when the aim or the representative that we are aiming does not exact or does not get on what we are expecting. Like there are shortages. So what is being said here is we must give an additional representative to those quota that have a largest decimal remainders. So I have an example here for us to fully understand it. Let's say, for example, we must apportion a 100 pence. So it has been divided into 3 states, which is A, B, and C. So calculating the quotient, calculating the quotient is the total number of the state over the standard quota. We get 33 or 33.486 for the state B. We get 29.816, and for the state C we get 36.67 for the standard quota. Standard quota aims to round down the quotient into whole number. So we have 33, 29, 36. So we must total all. So 9, 18. So we got 96. So based on the problem, we must apportion 100 pence. So we get 98. So we have a shortage of 2 pence. So in order for us to solve this problem, we must assign another representative to the state that has a highest decimal remainders. So as what we can see here, the highest decimal numbers or decimal remainders are 29.816 and 36.697. So we must just add 29 plus 1 and 36 plus 1. So it will have a total now of 33 plus 29 plus 1 equals 30. Then 36 plus 1, 37. So we must sum it all Here, we have also a 100 pence. So that just means that the problem that we solved using the apportionment of amount of land was distributed fairly on each state using the 4 steps. We are now down to our 4 basic steps, which are we must calculate first the standard divisor. Next is we must calculate the quota. Next, the third one, we must calculate the standard quota, which aims to round off the quota into a whole number. And lastly, we must evaluate our answer. If the answer is not appropriate to the given apportionment in the problem, then we must add one representative to a quota that has a highest decimal remainder in order for us to obtain the same number of apportionment given to the problem. So, for us to understand more fully, I have prepared 5 basic examples that you guys can easily answer it. So, let's answer it one by one. Here is the first example. A delivery company employs 65 delivery drivers. The company assigns each delivery driver to 4 regions based on the number of packages that need to be delivered in each region. So for the region, we have north, south, east, and west. So for the population in each region, we have in north 261, south 514, east 766, and for the west we have 1019. First step is we must calculate the standard divisor of the given problem. As what we can recall, standard divisor is the total number of population, or the total number of population divided by the total number of a person assigned in that specific problem. So in this case, we have the summation of 261, 514, 766, and 1019. So we have 514 plus 61 is equal to 2,560. 2,560. So we can now calculate the standard divisor. So 2,560 divided by 65 delivery drivers. So for the standard divisor, we have 39.384. So that's the standard divisor. For the quotient, we can now calculate the quotient using the standard divisor that we've calculated. So for the quotient, we can recall that the quotient is, we can get quotient by the total population of each state divided by the standard divisor that we've calculated. So 261 divided by 39.384, you get 261 divided by 39.384. So we have a quotient of 6.626. So same process with the south, east, and west. So So I will just calculate it using my calculator. So 540 divided by 39.384. 39.384. Then you get function of 13.050. That's 50. Then for the east, we have 760. So we have 19.449. So for the west, we have a calculation for 25.873. So we are now done calculating our portion. Then we can now proceed to the standard quota. So for the standard quota, the rule here is we must round down the quotient into a whole number. So we have 6.626, then we can have 6. Then for the south, we can have 13. For the east, we can have 19 and 25. Then we can now total this one. 6 plus 13 plus 19 plus 25. So it is just 63. So based on the fourth rule is we can add more representative if we did not meet the expected apportionment in that given problem. So based on the given problem, we have 65 delivery drivers. So we just have computed in the standard quota a total of 63 delivery drivers. So therefore, we must add more representative to those quotient that has the highest decimal remainders. So here we can see that 25.873 is one of the highest and 6.626 also. So we can add one representative to north and one representative to west. So we can now total it here to evaluate our answer. So 6 plus 1 is equals to 7, plus 13, plus 19, plus 25 plus 1 is equals to 26. So we can now sum it all to evaluate our answer. 7 plus 13 plus 19 plus 26. 7 plus 13 plus 19 plus 26. So we got a total of 65 drivers. So this just means that the apportionment using the numerical method that we calculated is correct based on the given problem. So we've got 65 here, so 65 here, so it is. So let us now proceed to our second example, which is, suppose a university has 20 scholarships. They would like to fairly distribute to the given apportionment on campus this scholarship using a chemical blood. So given the data in each department, biology, social work, nursing, engineering. So each student in each department has 240 for biology, 232 for social work, 105 for nursing, and 64 for engineering. So we must compute the total of the number of students. So 240 plus 232 plus 105 plus 64. We have 641 students. So first step, we must get the SD. SD is equals to 641 divided by the total number of scholarships. So we get divided by 1. we got 32.05. So we are now done putting in our standard divisor. Now let's proceed to put in our quotient. So again, quotient is the number of students in each department divided by the standard divisor. So 240 over 32.05. Then you can get a 240 divided by 7 equals 7.488. So I will just compute the remaining with the use of my calculator so for us to do that quickly. So 232 divided by 32.0, we get a 7.238. So for the nursing, we have 105. So we have 3.276. For the engineering, we have 64 students enrolled. So we have 1.996. So we have to sum it up. For the standard quota. For the standard quota, again, we must round down the quotient into equal numbers. So we have 7 plus 7 plus 3 plus 1. So we must total it 7 plus 7 plus 3 plus 1. So we have 18 students. So we are short here in our standard quota. So we must evaluate our answer by adding more representative to those departments that get the highest remainders. So here we can evaluate that engineering has 996 remainders. So we must add 1 here, and for the biology also because it has 488. So number 7 plus 1 plus 1. So that evaluate our answer here. 7 plus 1 is equals to 8 plus 7 plus 3 plus 2. So 8 plus 7 plus 3 plus 2. We get a total of 20 students. So our solution is now correct because it already has the same number of scholarships to the number of it is number of scholarships. So that's for our example number 2. So for our example 3, we have apportion 200 seats to the following 3 states. So here we have an event of 3 states, which is state 1, state A, B, and C with a total population of 155, 250, and 305. So we must total all 155 plus 250 plus 250 plus 305. So we have 710. So we can now calculate the standard divisor, which is 710 divided by the apportionment of 200 seats. 200. So SE is equals to 100 divided by 3.55. 3.55 is our standard divisor. So calculating our quotient, we have 155 divided by the standard divisor, which is 3.55. So 155 divided by answer, we get 43.661. For 250, for the state A, rather, we get a 250 divided by 3.55. We get 70.422. For the state C, we have 305. So we have 85.91. So for the standard total, we must get the whole number of this. So we have 43, 70, and 85. Then the summation of it is 43 plus 70 plus 85. We get 198. So again, same scenario as what we have in example 1 and 2. We have to have a additional remainders to those decimal that has a highest. We have here 85.915, so we have to add 1 here and also here for 4361. So 43 plus 1 plus 85 plus 1. So we have the total number of seats. 43 plus 1, 44, 70, 85 plus 1 is 86. So we have to get now the summation of the total seats, number of seats. So 44 plus 70 plus 86, 44 plus 70 plus 86, we get a total of 206. So that's right, that's correct. So let's now proceed to our example 4. For example 4, we have transportation company operates buses in Davao, Surigao, and Cagayan. The company needs to distribute the 40 buses among 3 locations based on the number of riders. So our location we have Davao, Surigao, and Cagayan, and the available number of riders for Davao is 528, for Surigao 540, and for Cagayan 431. So we can now calculate our SP. For the summation of this, we have 528 plus 540 plus 491. We have 1559. Then the total number of the riders, 1559 divided by the total number of buses, so 14. So SD is equals to divided by 14. So we have 33.975. So we can now get our equation by dividing the number of riders in the standard divisor. So 528 divided by 38.975. 528 divided by 38.975, we can now get 13.547. For Surigao, we have 540. So 540 divided by 38.975, we get 13.855. Then for the Cagayan, we have 491. We get 12.597. So for our standard total, we will turn this into a whole number. We have 13, 13, and 12. So total of 26 plus 12 becomes we have 38. So we have to add more representative to those quotient that has a highest remainder. So we have 13.855 and 12.597. So 13 plus 1 is 1. So we got the total number of buses 14 plus 13. Total number of buses is 13 plus 6 plus 14. We got 14. So our solution is now correct. We can distribute the buses into an accurate and more fairly way. So that's it for our example number 4. So we're down to our last example. So example number 5. Apportion 100 tokens into 3 sections. So here we are given 3 sections with each population. For section 1A, we have 73. For section B, we have 65. For section C, we have a population of 80 students, 80 rather. So we must calculate the total of this for us to calculate the standard divisor. 73 plus 65 plus 80. We have 218. So for the SD, we have to calculate 215 divided by 100 notebooks. So we get an standard divisor of 2.18. So we have a SD of 214, so that just means that we can calculate our quotient by dividing the population divided by the standard divisor 2.18. So 73 divided by 2.18. We've got 33.486 for section A. For section B, we have 65 population. So we get 29.86. And for the last population C, we get 80. Then 80 divided by 2.18 is equals to 36.697. So this quotient we must turn into a whole number. So 33, 29, and 36. Then we must have the summation of this. 36 plus 33 plus 29. We have 98. So same scenario, we must add more representatives to those population who has the highest decimal remainder. So here we can clearly see that it is population B and population C. So therefore, we must add more representative here. So 29 plus 1 is equals to 30, 33, 30, and 37. So calculating the total number of notebooks, we have 37 plus 33 plus 30. We get total of 100 notebooks. So as what we can see, we got a correct answer. We can now distribute fairly the notebooks into 3 sections. So again, that's our last example. So I hope you've learned something today. So let us not forget that apportionment plays a vital role in shaping our future. So it really helps us when it comes to dividing fairly, when it comes to some stuffs here in our community. So, and that's the end of our lesson for today. Just a quick recap, we've tackled about apportionment by Hamilton's plan, which indicates 4 basic steps. So we have the standard divisor, the quota, the standard quota, and we must evaluate our answer on the 4th step. So in getting the standard divisor, we must calculate the total number of the population divided by the given apportionment in the given problem. So for the quota, we must divide the population in each state divided by the standard divisor that we get during the first step in our calculation. Then for the third steps, which indicates standard quota indicates that we must round down the quota into a whole number. So for the last step is evaluate our answer. So if the standard quota did not get on the quota that is expected, then we must add more representative to those population or to those state that has a highest decimal remainders. So that's it. I hope you've learned something today. Again, my name is Adel and Valle, and this is my report with the topic of a Hamilton plan, apportionment by Hamilton plan. So thank you everyone.